Hi, I'm Lee Teschler, Executive Editor of Design World magazine.
And I'm Michelle DiFrangia, Assistant Editor of Design World magazine. Today we are looking at pieces of an LED bulb from Philips Lighting. Of the several other 60-watt equivalent bulbs we've examined, this one is manufactured in China. But it's not at all put together like the other bulbs from China we've previously looked at.
Right. This one probably has the most elegant mechanical design of the five we looked at. There is a two-piece shell that both holds the LEDs and the electronics, and it also is the structural support for the metal screw threads and the contact foot. So the whole bulb is quite simple and takes a different approach from several other bulbs we've looked at. One noteworthy point about the Philips bulb pertains to heat sinking. The other bulbs we examined had metal heat sinks ranging in weight from 1.3 to 3.8 ounces. The Philips bulb manages to handle thermal issues without any extra heat sinking at all. The only component that spreads heat is the 2.5-inch diameter metal disc onto which the 26 LEDs mount, 13 to a side. Moreover, you might expect that designers would stagger the LEDs on the disc such that they wouldn't mount directly opposite each other. This mounting arrangement would also help spread heat. But the LEDs on either side of the disc sit directly opposite each other. It appears that LED heat just wasn't an issue in this design.
Well, that's surprising. Why no heatsink?
One reason is the presence of a negative temperature coefficient thermistor on the LED board. Philips probably adjusts the LED drive levels as things heat up. That resistor is really small and it's easy to miss it when you look at the LED plate, but that's certainly what it is. I tried to examine the board traces to figure out the temperature compensation network, but the PCB has 3 layers of trace routing, one hidden, so I couldn't really do that. Further complicating the analysis of the circuit is the fact that 2 6-pin ICs seem to handle the AC-DC conversion, and neither is marked with either a manufacturer's logo or part number. Because the main ICs can't be identified, we can only hypothesize about how the LED driver works. The presence of a transformer, 2 large capacitors, and an NPN power transistor, which comes from STM Microelectronics, might indicate that the converter has a flyback design, though there are certainly other topologies that could also use these same components. But our guess is that the temperature compensation network is in the biasing of the switch providing current to the LEDs from the flyback transformer. 2 transistors seem to handle the LED current. In all, we counted 32 small discrete components made up of resistors, diodes, and capacitors. This LED bulb is dimmable, so some of those components are likely to be part of the dimming network. Rounding out the board components were a bridge rectifier chip and 3 other power capacitors.
Flyback sounds like something you do when you come back from a long vacation. What is that?
Well, briefly, a flyback converter uses a power transistor to switch the current flowing through the primary of a transformer. When the switch is closed briefly, current flows and the transformer briefly stores energy. The switch opens and the stored energy then transfers to the transformer's secondary, which in this case is connected to a load consisting of the 26 LEDs.
So compared to the other 4 LED bulbs we've examined, how do you think this one stacks up?
One thing we've learned is that the mechanical design of an LED bulb that contains no heat sinking can be quite simple. Some might even call it elegant. The Philips bulb certainly weighs the least of any of the bulbs we tore down, and the weight difference is significant. The Philips bulb is basically a plastic enclosure that encases the LED plate and driver PCB while also supporting the metal screw threads and contact foot. The only other components are 4 wires that connect the PCB to the LED plate and to the foot contact and metal threads. That's it. Now, the form factor for this bulb differs from that of others because of how Philips decided to house the 2-sided LED plate. The Philips bulb isn't so much a bulb as a disc. Encasing the LEDs so the bulb looks flat might seem a little weird to people who expect something called a light bulb to actually be shaped like a bulb. And it doesn't give off uniform light because of the disc shape. The light is concentrated on the 2 flat sides of the bulb, so I suspect some people might be put off a bit by the flat shape. If you don't mind the shape of the light pattern, this bulb puts out a nice warm light that's pretty close to that of a 60-watt incandescent.
So Lee, if you had to pick one, which of the 5 LED bulbs you've looked at would you install yourself?
Well, there are dozens of LED bulbs on the market, and we've only looked at 5 of them. though the ones we looked at all got high ratings from Consumer Reports. So this really wasn't a contest about which one was better. I've already tried to install LED lights in my house. My wife has always instantly vetoed them because the light they give off historically been pretty harsh. The Philips bulb we looked at today was a color temperature pretty close to that of an incandescent. So if I installed it, I think she might not notice any difference. Besides, I think its design is pretty neat. So personally, I might go with this one, but it's really a personal decision.
Okay, well with that, we'll have to turn off the lights on our LED bulb teardown series. If you want to see the teardowns of the other LED bulbs we've examined, check them out at designworldonline.com, and thanks for watching.